Okay, let's take a look at lesson 9. How do I use coordinates to find perimeter and area of geometric figures on the coordinate plane? So in this lesson, we're going to be graphing a variety of, geometric figures, different polygons, triangles, rectangles, squares, trapezoids, etc. And we're going to use the coordinates to help us to find area and perimeter. Let's do, a couple examples together. You're going to have your own chances to draw your own figures, but let's come up with some on our own. Let's start with maybe a square. Maybe I'll put the square right here. Notice when I make the square that every side is the same length around. This side is 3 units long, this side is 3 units long, 3 units there, 3 units there. It's very easy to find the perimeter of the square because all I have to do is add up all the sides. 3 plus 3 plus 3 plus 3. That's going to give me 12 units. Area, of course, I know I can just do base times, well, actually side times side, which would give me 9 square units. Okay? Now, I want you to take notice of the coordinates that I have here. Let's see, down here on the left corner, that is 3, 2. The location of the corner point is over 3 up 2. This one would be, let's see, 6, 2. This one up here would be 6, 5. And this one over here would be 3, 5. I want you to take notice of some of the patterns that you see in our coordinates. Do you notice that the x coordinates are the same here and here? Both of them start at 3. That's because you're going over 3 before you go up to or before you go up to 5. So the same thing happens here. In your vertical, if you look at the lines that are vertical, the vertical lengths, you can see that the x's are the same. The ones that are different are the y's. The y's are the different ones. Take notice, if you were to do 5 minus 2, you would get that length of 3. And same thing over here, 5 minus 2, you'd get that length of 3. So on the vertical lengths, if you subtract the y coordinates, you will have the measurements of those two vertical sides. I could do the same thing for the horizontal sides as well. Take a look at this side. Here, do you notice how the y coordinates are the same, but the x coordinates are different? Think about it. What's the difference between 3 and 6? 3. Same thing down here. The y's are the same, but the x coordinates are different. What's the difference between 3 and 6? 3. Let's take a look at that same idea, but with a rectangle. Let's see. I'll put the rectangle right here. Obviously, it has a length of 4 and it has a width of 2. So we know that our perimeter, if we add up all the sides, that would give you 12. And if you were to multiply length times width, you would get 8. So 12 units for the perimeter, 8 square units for the area. Now, let's look at the coordinates of the corners of our rectangle. Let's see, right here, this corner is 2, 6. This corner here is 2, 4. This corner here, this corner here is 6, 4. And then this corner up here is 6, 6. So once again, take notice of some of these patterns here. Look at the vertical ones. Here, your x coordinates are the same, but your y coordinates are different. 6 minus 4 is 2. Same thing over here. 6 minus 4 is 2. The x's are the same on the vertical lines, but the y's are different. How about the horizontal ones? Here's the two horizontal lengths, and you can see that this time the y coordinates are the same, but the x's are different. 6 minus 2, there's your 4. And same thing down here. 6 minus 2, there's your 4. What if you have a triangle? You can make a triangle on the coordinate plane. You can put that anywhere you want. Maybe I'll make a right triangle. So it would look something like this. Now this one it would be kind of hard to find the perimeter of, and that's simply because we know this is a unit, a length of 3 units. We know this is a length of 3 units, but this one we don't know. We could figure that out if we solved it using the Pythagorean theorem, but we're not there yet. So since we don't have that missing side, we can't really find the perimeter. We can find the area though, because you know it's 1/2 base times height. So for the area, we have to do 1/2 times the base times the height. So that would give me, let's see, half of 9 would be 4.5 square units. Okay. How about, let's move on to a parallelogram. I'm going to do a different color. How about orange? I'm going to make a parallelogram that has bases of 4. Notice that I made sure each base is the same length, because I know in a parallelogram I'm going to have 2 bases that are the same length. And then here are my other diagonal parallel sides. Now these, again, I do not know exactly how long they are, so I can't really find the perimeter here. I could find the area, however. I see my base is 4, and if I draw a line to make my height, I can see my height is actually 3. So I'd have to do 4 times 3, which would give me an area of 12 square units. Also take notice of the coordinates. I don't think I talked about the coordinates here. You know both bases have a length of 4. Well, let's look at the coordinates of the corners of our parallelogram. Here we have 5, 3, and over here we have 9, 3. Up here we have 10, 6, and over here we have 6, 6. Now I want you to take notice of that pattern we talked about before. I want us to focus on the horizontal bases here. So let's look at the top. Now you know if it's a horizontal line, we're going to end up having y's that are the same, but the x coordinates are different. What's the difference between 10 and 6? There's the 4 that we had originally. Look down here. Here we have our x's being the same, our y's are the same, but our x's are the ones that are different. What's the difference between 5 and 9? There's your 4 again. So this time we had some different numbers, but even when we subtracted, we still saw our both bases being 4 in length. And how about a trapezoid? You could even draw a trapezoid if you wanted on here. And I can have a little bit of creative fun here. I could make an isosceles, I could do a right, I could do an irregular trapezoid if I wanted. Now this one, again, I don't know the lengths of the slanted lines. They're a little bit harder to determine, but the top is 3 units long and the bottom is 5 units long. And I also can see my height here is 3 units long. So I can figure out the area of this trapezoid. I may not be able to find the perimeter, but I could find the area. And I have to do 1/2 times the height, which is 3, times the bases that I have to add, 3 plus 5. Now remember, I'm going to do what's in parentheses first. So now I have 1/2 times 3 times 8, and let's see, that would give me 12. 12 square units. Hopefully you're getting the idea here. Okay. Now, in the workbook, you're going to have lots of opportunities to, draw your own polygons and find perimeter and find the area. But I want us to look at workbook page 70 right now. This is something I really want us to focus on. We're going to do numbers 13 through 16 together. Find and label these points with the letter and the coordinates given. Then connect the points and find the segment length. So let's see, E, that's at 1, 9. So over 1, up 9, here's my E. That's at 1, 9. Okay? And then I have to do 1, 12. I'm going to have to move my E here then. I'll put E down here. Okay, so 1, 9 and then 1, 12 would be right up here. and that is F. So I have my coordinates, I labeled them. Now I'm going to connect them, and you can see that I have a line segment. The length of EF, well, obviously the length is 3 units long. You can see that from one dot to the next, 3 units, 3 squares. How about the next one? Let's look at number 14. Let's see, 6, 8 over 6 up 8 right around here. Okay, and that is H, 6, and 8. And let's look at 8, 8, which would be K. 8, 8 is right here. That's K at 8, 8. I can connect them, and you can see that that one is 2 units long. The length of HK is 2 units. Now look at the coordinates of points E and F and the length of segment EF. How can you find the length of this vertical segment without graphing? Imagine that you didn't have the coordinate plane there anymore. Imagine the grid lines are gone. How could you find the length of this vertical segment without graphing it? If you remember, on the last slide I talked to you about how you could subtract the coordinates, and notice that you'll see the length that way. Here, if this is a vertical line segment, I can see that my x's are the same, but the y's are different. I can subtract the y coordinates. And of course, 12 minus 9 is going to give you that 3. Let's do that same thing, but now we're looking at number 16, the coordinates of h and k. How can we figure out the length of segment HK without graphing it? Imagine that we didn't graph it. Could we just use these coordinates, 6, 8, and 8, 8? In this case, you can see that the 8's in the y coordinates are the same, but the x coordinates are different. Find the difference between them. Subtract the x coordinates. So in this case, I could subtract 8 and 6, and there's the 2. Alright, so workbook page 70, number 17. Without graphing, find the length and direction of a line segment with endpoints at 12:10 and 12:2. Well, do you notice that the x coordinates are the same? The x coordinates are both 12. The ones that are different are the y coordinates, 10 and 2. Because the y coordinates are different, I know it's going to be on the, it's going to be a vertical line. If it helps, think about the coordinate plane. You know that the y-axis is the vertical line and the x-axis is the horizontal line. So here, since our y coordinates are different, I know that this is going to be a vertical line, and I can subtract those y coordinates. 10 minus 2, it's going to be 8 units long. Look at number 18. Without graphing, find the length and direction of a line segment with endpoints at 0, 7 and 6, 7. This time the y coordinates are the same, but the x's are different. Since the x's are the ones that are different, I know it must be a horizontal line, and I can subtract those x coordinates, 6 minus 0. When I say subtract, don't worry so much about the order. Think about the difference between 0 and 6, and that will be 6 units. We're learning this so that when we come across problems like this from workbook page 74, you'll be able to find, the area of different, triangles and rectangles and squares just using coordinates. You won't even have to graph it on the coordinate plane. Let's do one or two together. Let's look at the swings. Here are the swings. It's a triangle, which means we need the base and we need the height. Okay? Let's start with the base. Notice that the base is a horizontal line, which means I can subtract the x coordinates, and my x coordinates here are 6 and 0. 6 minus 0 is 6, so I know the base is 6. Now let's look at the height. The height is a vertical line, which means I can subtract the the y coordinates. I'm going to do 12 minus 6, which means I'm going to have 6. And now I have what I need to find the area. Base times height, or 6 times 6, which is 36, and cut that in half. Okay, and that will be 18, we'll just say 18 units squared. I don't really know what the units are here. Let's go to the slide. Alright, so here's our slide. We have a base, we have a height. Let's start with the base. So the base is a horizontal line, which means I can subtract the x coordinates. 13 minus 6 is 7. Now the height, I'm going to have to subtract the y coordinates. That will be 12 minus 6, which is 6. And now I'm ready to find the area. Base times height is 7 times 6, which will give me 42. Cut that in half, and the slide is 21 square units. See how you can use the coordinates and figure out the area without even having to graph it and counting squares? Kind of cool, huh? Alright, so here are the takeaways. Area and perimeter polygons on the coordinate plane can be found by identifying the lengths of needed dimensions using the coordinate grid. You can use subtraction to find the length of a vertical or horizontal line segments when the grid isn't present, or when you only have coordinates. For vertical line segments, remember to subtract the y coordinates, and for horizontal line segments, remember to subtract the x coordinates.